Okay, so good evening once again. So today we're going to create a new project. We're going to use machine learning to do supervised learning. So we're going to load first tidyverse and then use the R read underscore CSV, which forms part of your readr package, to access our cardio dataset. So here I'm creating this object cardio using the read underscore CSV, okay, which I said is part of read R package, which comes with tidyverse. Okay, and then we're using this read underscore CSV. And we just need to identify the file name because the file name is already loaded in our files in the project directory itself. And then column names is equal to true. So we can now run this. Okay, and we now have this data cardio. Okay, let me pause for a while and ask you if you were able to load the cardio dataset. Were you able to do that? 2,126 observations of 22 variables. Anyone needing help, please?
Sir, yung sa akin, pag dina-download ko yung CSV file, ano siya, HTML or
HTML? Okay, sandali ah. Okay.
Dina-download sa akin.
All right, let me, okay. Hindi naman siya nakabukas, ano? No, it's not open. So let me share that with you. I-chat ko dito, no? Para, okay. Ba't kaya HTML? Strange. Okay. This one. Can you please check, Tim, kung that CSV na yan, ha? Okay. Doon sa sa Canvas, that CSV din yung inano ko eh. Sinare ko eh. How about the others? Na-load nyo ba?
Yes, sir. Okay. CSV.
Okay na? Okay, good. Okay, Rose, thank you. Yung iba, Jonah, Cayenne, Rap, were you able to load the data?
Not yet, sir. We'll try po. Wait lang.
Sige. Pag may problem, sabihin nyo lang, sabihin nyo kasi we will not continue without you being able to load the data. You have to load it first.
Sir, pati po ba yung Excel?
No.
Or yung CSV mo?
Yung cardio lang, cardio.csv.
Okay po.
Dali lang, let me just turn off the cell phone. Okay. So kindly inform me if you were able to. Thank you, Cayenne, si Rose. So sino pang hindi nakaka-load? Rap, Team, Jonah. Were you able to load the data? Okay, thank you, Tim. Thank you, Jonah. Rap, ikaw, na-load mo na yung data?
Hangin there, sir. May naman po. Wait lang.
Sige lang. If you have problems, inform me. Pause recording po. Okay, yan, sige. All right, Rap, kindly share your screen again. Share,
All right, yes, sir.
okay, tingnan natin. Okay.
Let me share
Yan,
the
alam ko.
whole thing.
Okay.
So
Ayun,
I have this now.
on the upper right, kita ko na yung decision tree. Andyan ka na sa
Okay.
Yan, andyan ka na sa sa directory ng
Yeah.
project. And
Opo,
then you go to the folder, doon mo i-save yung i-save mo doon yung file. Wag anywhere kasi hindi mo that defeats the purpose. Where's the
This one earlier.
so yan na.
Pero teka, let me just rename it, sir. Para exact siya talaga.
Sige.
So this one, so this is the file I downloaded.
Yan, okay. So andyan
And
na,
then,
Sige. So i-close mo na yan. I-close mo na yung
okay.
You should now see that. Okay. Bakit wala dun sa Dapat
It's, ayun naman siya. Refresh ko lang, sir.
sige. Could you kindly go back to the folder that you saved?
Here it is, sir.
Okay.
Ayan siya.
Dapat andyan din yung project. Dapat andyan din yung project na create. Saan yung project? Backspace mo. Wala dyan yung project. Wala
Oh, this one. Okay.
Dun mo
Okay.
dun mo ipasok dun sa wag dyan. Ayan, dapat makikita mo yung art project there. Okay. Kung saan naka-reside yung project, now you can see the cardio, di ba?
Yes.
Yon. Okay. So you can now open ka na ng bagong R Markdown. Sige. Yan. Okay. Sige. Okay ka na.
I title it.
Sige. Okay. Yeah. It's up to you what title you want to put there.
And then this one's for HTML pa rin.
Okay lang yan. Default naman yan. So, pag naman yan, pag rendering na yan. Yan na. Tapos, sige. I-erase mo na yung mga dyan, yung R Markdown na Yan. Sige. Yan, hanggang taas yung Yan, yung R Mark yan. Tanggalin mo na yan.
Hanggang dyan, sir. Tama yan?
Yan, tanggalin mo na yan.
Okay.
Yan, tapos mag-library ka na. Mag-create ka ng panibagong create a new code chunk. Yan. Library mo yung tidyverse.
Tidyverse.
Yan.
Tapos run, sir.
Enter, run mo. And then, i-load na natin yung data mo.
Okay.
I-ex mo na yan. I-ex mo na yung mga packages that come with You notice na kasama yung readr, di ba? Okay, sige. Create another code chunk. Okay, then okay, let's create an object called cardio. And then yung assignment operator.
Sorry.
Yung greater than tas minus, na shortcut nun. Hindi mo shortcut
Hindi ko dala yung notes ko, sir. Teka.
Sige, okay lang. Kahit mamaya na yan. Alright, then read underscore CSV.
I find notes right.
Read underscore CSV. Yan, ba? From the readr package. Open parenthesis. And then quotes. Cardio.csv, yun na, diretso na. No? Kasi quotes ka muna. Yan. Alright, then comma. Comma. Lagyan na natin column underscore names. Yan. I-tab mo na lang yan. Is equal to T, true. Kasi may column names tayo. Alright, then run that. Ayan, yan na. Nasa data mo na si cardio.
Alright. Yes, sir.
Okay, good. Okay.
Okay, got it, sir.
Alright. Okay, thank you. Share ulit ako ng screen, ha? Okay, thank you for that question, Rap. Okay, it's always good to have questions like this kasi nare-review din tayo, no? Okay, so let's take a look at our data. Okay, all right. We have so many variables here. These are actual data too, no? 2,126. And these are medical data. We will not anymore look at the significance of this, yung mga ibig sabihin nito. But this is normal. This has something to do with the heart condition. Normal, suspect, at saka pathologic, NSP yun ang ibig sabihin. So this is a factor. 1 means normal, S means suspect, and P means pathologic. So ito yung actual na diagnosis dun sa patient. Okay, so we have here yung data na to. LB I think is in pounds yata. And we have I'm sorry hindi ko na ibigay sa inyo yung metadata, ibig sabihin information about the data. But we're going to use certain variables here in order to try to predict NSP, which is like your regression. Parang regression type siya na modeling. Kasi yung machine learning, one of the tools in machine learning is regression using decision trees. So it's different from the OLS na natutunan natin dun sa yung mga regression, yung stat na subject nyo dati. Kasi yung stat na subject nyo dati, gumagamit siya ng ordinary least squares. Ito, decision tree, no? So which is a tool in machine learning. And that's what we're going to look at. It will be good if you also run this using yung nung nag-ano ba kayo, nag-stat kayo, ginamit nyo ba si R? Class. What software did you use when you had your multiple regression, time series? Anong software yung ginamit niyo?
Sir, yung sa stat, Jamovi.
Jamovi. Okay. Pare-pareho kayo, Jamovi?
I also use Statistica, sir, on top of the movie.
Okay. Okay. So wala siyang gumamit ng R.
No, sir.
Okay.
Wala, sir.
Ngayon, class, actually pwede na kayong you can go to the internet and YouTube. Marami na kayong pwedeng tutorial na pwedeng tingnan kung how to do multiple linear regression in R. And it's quite easy, no? Napaka-powerful ng R sa mga ganyan. And what's good about it is that you can now do that on your own. You are now empowered kasi naintindihan nyo na no? Medyo comfortable na kayo navigating through R. So when you try to learn multiple linear regression in R, it will be very easy kasi what we have been learning are more difficult than the ordinary least squares method. Simple lang yun. So, but before anything else, let's take a look at the structure. Tingnan natin structure ng cardio. Tingnan natin kung ano ba yung laman nito, no? Okay, tingnan natin si cardio. So it's a table. It's a special table. Data frame siya. So we have here 22 variables, 2,126 rows observations. All right, and here are the variables LB, AC, FM, UC, LC. So these are all mga body details, mga body metrics. Okay, tapos may kasama mga stat, no, mean, median, variance. Okay. And then here you can see yung data type niya. LB is double, which means numeric siya, no? Column numeric, column double. So all of these are double. Even NSP, no? Si NSP is numeric, which is supposed to be factor siya, di ba? Na-discuss niyo ba sa regression yung factor? A factor is supposed to be a variable that can be considered as a classifier. Kasi si cardio, hindi naman siya numeric eh. Ano to, yung classifier siya. 1 means normal, S means 2 means suspect, and P means pathologic. So we're going to convert this variable, we're going to convert this. Kasi ito yung ano natin, class, ito yung variable of interest natin. Okay? Itong NSP na to. Tatlong level siya, 1, 2, 3. So if we're going to carry out regression, kung tutusin, hindi pwedeng, hindi po pwedeng multiple linear regression. Kasi ang multiple linear regression, yung dependent variable natin should be a continuous variable. This one is categorical. So, hindi siya logistic kasi pag logistic, 1 or 2 lang yan. True or false, yes or no, or 1 or 2. So ito tatlong levels. So actually ang gagamitin dapat na method dito is multinomial linear regression. I don't know if you discussed multinomial linear regression. Multinomial is used when you're predicting a variable that has more than 2 categories. Pag dadalawa lang siya, logistic regression. Pag more than 2, multinomial logistic regression na yan as compared to a binary logistic regression. Alright, so ito yung structure niya. Tinan na rin natin yung as usual, yung pwede natin tinan din. Summary. Ay, hindi pala tayo Hindi pala tayo nag-regression kaya I didn't discuss with you yung mga gantong functions. Summary will give us yung 5-number summary. Yan, si LB. Bibigay sa atin yung minimum, maximum, first quartile, second quartile, third quartile, plus the mean. So since these are numerical variables, merong may ganyang metrics, no? And kasama pa si NSP, na dapat hindi naman kasi hindi naman numeric si NSP. Okay? So what we're going to do now is i-convert natin si NSP into a factor. So let's write that here. Okay, convert NSP variable into a factor. Okay, just to check, Control Alt I. Tingnan natin yung class ni class of cardio dollar. Okay, dollar yan NSP. Yan, take a look at this code. Tingnan natin kung anong type ng variable si Although alam natin na numeric kasi nakita na natin sa structure kanina. But nevertheless, let's just get the class of NSP. No? Right, so that's the function. Class of hindi by the way, hindi mare-recognize kung si NSP lang. Class NSP, mag-error yan, Control Enter, because there's no such thing as NSP as far as R is concerned. Diba wala namang data dito na NSP, no? NSP is a variable contained in cardio. So you have to define, in fact, when you run this, cardio, pag nag-cardio kayo and then $sign, you'll notice that it will give us different variables under the cardio object. Okay, isa doon si NSP. Ayan. And then tab para ma-print si NSP dito. And then if we run this, yung class, you can see that this is numeric. Okay, and we don't want that. Gusto natin si NSP should be treated as a factor or a classifier. Right? So, clear na si NSP is a categorical variable. So, in R, it's very easy to convert that into a factor. Sige, lagyan natin. Oops, dito na lang. No? To convert, so that's cardio. Diba? Cardio, dollar. Now, what you can do is, pwede nating palitan na tong pwede nating palitan tong NSP. Gagawin nating factor yan. Or we can create another variable. So let's just create another variable. No? Let's create NSP as a factor. So I'm going to create a new column in cardio. So sa cardio, sabi cardio, $NSPF. So we're going to create another variable called NSP, but as a factor. then alt minus, then as that factor. So medyo nagko-konting regression na rin tayo dito sa R natin. As that factor, and then cardio, dollar, NSP. Okay, what are we saying here? Okay, create a new variable, NSPF, and then yung variable na yan is it's NSP pero treated as a factor. So that's what that means lang. All right, so let's run this. Okay, you can now see that if you ulit natin si NSC cardio, if I click this, all right, kanina 22 entries lang to, no? 22 total columns. Kaya naging 23 na. Take a look at this. Yan. Because when you go to the right, okay, meron na tayong panibagong variable. Yan, NSPF. Ayan. NSPF yan. So this is the new variable that we created. And if we take a look at the class of this object, tingnan natin. Class ni NSP, ni cardio dollar, NS, yan, makita nyo, lumabas si NSPF, no? There. All right, let's get the class of that, and it's a factor. Okay, pag factor, ibig sabihin nun, it's used as a classifier. Okay, if this was ordinary least squares, may I ask you, what will happen if it's converted into a factor, if you introduce a variable that's a factor? Can that be used as a part of your regression? What did you learn in your previous stat subject? Pwede ba maging predictor ang isang factor, ang isang categorical variable? The answer is, okay, let me refresh your memory. The answer, of course, is yes.
Yes.
Yes, thank you. In fact, anong ginagawa dyan? Yung mga statistical packages, ang ginagawa dyan, ini-introduce nila as a dummy variable, diba? If you recall, ginagawang dummy variable yan. In this case, how many dummy variables would be introduced if we were going to use OLS? Would you know? Okay, so konting review na lang ng stat to, no? For the benefit of everyone din naman to. Okay, what happens is that mag-introduce siya ng, wait, dali lang. It will introduce, okay, punta natin tong cardio natin. Alright, itong NSPF na to. It will introduce how many dummy variables? 2 dummy variables. Where did I get 2? Kasi tatlong levels. 1, 2, and 3. 1 is normal, 2 is suspect, 3 is pathologic. Ibig sabihin may sakit, no? Yun ang findings ng mga doktor. Alright? So, what happens is that itong NSPF na to, i-convert to into 2 dummy variables. Alright? So, magkakaroon ng 2 dummy variable. Okay, oops. Okay, yung isa pwedeng maging kay R, kung sino yung mag-a-appear first, either alphabetically or numerically, siya yung gagawing benchmark variable. So, si normal, since siya yung 1, siya yung gagawing benchmark. Therefore, gagawa lang ng 2 dummy variables for S, suspect, at saka kay P. Alright, so how will this look like? Sa regression, kunyari itong 2. No? Itong 2, i-convert to into, so 2 is suspect. So 1 at saka 0. Yan. Asa na si normal? So si normal dito, 0 siya. No? So suspect is 1, pathologic is 0, and normal is also 0. So ang suspect yan, 1. How about this one? Yung 1 na to, normal siya. So how will your dummy variable look like? 0 si suspect, 0 si pathologic. Okay? Kung parehong 0 to, 0 si suspect, 0 si pathologic. Therefore, normal yan. That's why we only introduce 2 dummy variables. Otherwise, in your regression, this is just a quick review. If you have 3 levels in your factors, and if you're going to introduce 3 dummy variables, magkakaroon tayo ng multicollinearity, magkakaroon tayo ng dummy variable trap, no? So that's why the dummy variables that's introduced in OLS is the number of levels minus 1. Okay, because the number of levels minus 1 is already sufficient to accommodate, to capture all your data. Okay? So kapag dalawang 0 to, si S at saka si P, ibig sabihin 1 yan. Kung si P, ito 3. Si pathologic yan, di ba? So ang mangyayari niyan, it's represented as 0 kay suspect, 1 kay pathologic. Di ba na-capture? Lahat dyan maka-capture with just these two dummy variables. Okay. So just a quick review. All right. So going back to our code now. All right. So we have converted si cardio, si NSP as a factor. Pwede rin namang class, pwede rin namang NSP na lang din. Pag NSP yung ginamit natin dito, papalitan talaga niya yung NSP. Hindi na siya mag-i-introduce ng another variable called NSP. Alright? Okay. So sa machine learning, ang gagawin natin dito, ang objective natin is to use a model in machine learning, and the first model that we're going to use is decision trees. So we're going to use certain variables, and then ang gagawin ng model natin, i-predict niya kung based on these two variables, kung N ba, normal, o suspect, o pathologic yung patient. Tapos titingnan natin how the model perform. Parang regression, no? Parang regression din. Pero ito, ibang methodology yung ginagamit. Okay, decision trees. Alright, so let's go here. Now, sa machine learning, what's done is that you don't make use of all the data. No? Bakit natin hindi gagamitin ng lahat ng data yung 2,126 observations? Ito. Why aren't we going to use all of this in order to create a model to predict kung N o S o P ba siya? Kasi if we're going to use all of this, magkakaroon tayo ng what we call overfitting. Ano yung overfitting? What's overfitting? Gagamitin lahat ng observations na yan. Okay? So pag may it will become a model that that since we're using a lot of observations, so wala tayong matitira na para i-test natin yung yung model natin. So what happens is that oftentimes ang ginagawa, ini-split yung data, no? Data is split oftentimes into 3, no? So we have your training data, and there's another one, hindi na natin i-discuss to, no? Siguro magbibigyan tayo ng example dito. And you have your testing. For our purposes, dalawa lang yung titingnan natin na split or partition ng data. Training data and then testing data. So what will happen is that we're going to split this 2,126 observations. Split natin siya. One portion will be used to create your model using decision trees. And then once it's done, we're going to use that model and try it on the data that has not been seen by the model, right? So di ba, i-split natin tong 2126 na to. A portion of that will be used, gagamitin natin, imo-model natin. So magkakaroon tayo ng model, tapos gagamitin natin po ngayon, we're going to use the model on the testing data and see if our model is still able to predict using the test data and how effective it is. See, a model is effective if it's able still to come up with a good prediction rate dito sa testing data natin. Okay? All right, so let's now go to how this is partitioned. Lagyan natin dito partition our data. Okay. So paano natin pinapartition to? Okay, did I discuss with you and then, no? Kasi hindi naman tayo nag-regression sa subject natin. Pero paano natin ipapartition to? How do we split the data? we will be using randomization. No? Okay? Now, pag randomize kasi, magiging magkakaiba tayo niyan, di ba? So we cannot possibly have the same kunyari, split natin yung cardio data natin. Let's say 70% will be used for your testing, training, and 30% will be used for your testing. Or maybe 80%, usually it's between 0 to 0.70 or 60 to 70%. We put to our training data, even 80%, and then the rest will be using to test our model using the testing data. All right. Okay, so the one way to go about it is let's create this object called PD. So that's partition data. And then we're going to use the sample. Okay, yung sample function. But before we do that, tingnan muna natin class ko ano yung ginagawa nitong sample na to. So question mark sample, we're going to make use of this. All right, sample, this comes from the base package. Okay. So sample, sabi dito, takes a sample of the specified size from the elements of X using either with or without replacement. So meron tayong data, kukuha siya ng sample doon. Okay, either with or without replacement. So this is the syntax. From your X data, anong size ang kukunin natin? So either with replacement or without replacement. What's the meaning of with replacement? Ang ibig sabihin ng with replacement, pag imagine a container with let's say with ping pong balls, different colors, kunyari, doon sila lahat. O kaya marbles or whatever object you have there. So when you draw out from that container, okay, you take one. Pag sinabing with replacement, pwede mong ibalik yung marble na yun doon. So ibig sabihin, pwede makuha ulit yung that specific marble. Pag without replacement, pag kinuha mo na yung marble na yun, hindi na siya pwedeng ibalik. Kasi without replacement, hindi na siya i-replace. Alright? So we can now split our data using this sample function. Okay, so let's create this sample. All right. So in how many sets are we going to split our data? We're going to split it into two, di ba? All right, into two. Then ano yung size ng data natin? We have 2126. Okay, so ang gagawin natin dyan, split into two yan. 2126. Of course, it's not good to put 2126 there. Gamitin natin si nrow. Nrow ni cardio. Okay? The nrow of cardio, the number of rows of cardio is 2126. So that's more, that's a lot better than just typing 2126 there. Right? And then, usually what's done is replacement is equal to true with replacement. To. And then the last is we will identify yung probability, yung distribution natin. So ang prob natin is equal to C, concatenate natin. So ilang percent yung ilalagay natin sa testing data, sa training data, at saka sa testing data. Since malaki naman tong relatively okay naman tong size ng natin ng observations, we can use 80% kasi 80% yan is around 1,600. So that means mga 400 thereabouts for our testing data. Okay na yun. So let's put here 0.8 and comma 0.2. Okay. All right. Sige. So let's run this and let's see what happens. So now we have here PD. All right. So ano tong PD na to? Ano nangyari to? 1, 1, 1, 2. So if I view PD, for example, let's view this. I-view natin. View PD. Alright? Hindi. Okay, ano na lang? Head. Sorry, ano nga pa to? Head PD. PD yung first 20. Okay, the head function will give us the first X observations dito, 20. All right. So I'm having 1, 1, 1, 1, 1, 1, 1, then 2, 2, then 1, 1, 1, 1, 2. Do you have the same distribution of 1 class? And what does this mean? Kasi we're splitting it into 2, no? 80% will go to 1. Ibig sabihin, ito yung training data natin. Yung 2, yung testing natin. So, mas maraming mga 1 sa pag-split niya kasi 80% yung binigay natin na 1, di ba? Now, my question is, do you have the same values of 1, 3, sa akin 3, and then 6, and then 8? 8 na 1, tapos dalawang 2, tapos 1 sa naman. Could I have a show of hands if we have the same? If we have the same values?
Not, sir. No.
No,
No, sir.
of course not. No? Bakit? Kasi random yan eh, di ba? Sampling yan. Okay? So, pag ganyan kasi, hindi tayo makakapag-generate ng parehong answers. Right? Kasi your sample now is different from my sample. Iba yung training data mo, iba yung testing data ko. So, to address that, buti lang ma-answer kay Art, no? We can now put here a set.seed function. Ito yung mga dinidiscuss namin sa regression, no, in my other subjects kasi regression yun eh. Okay? So set.seed natin. Yung set.seed will allow us to come up with the same samples, no? We just have to identify a particular number. Kunyari 1, 2, 3, 4. It can be any number. Basta pare-pareho tayo, no? So let's just use 1, 2, 3, 4 for the purpose of generating the same sample. All right? Sige, i-run natin to ngayon with the set.seed and then tingnan natin yung head. Yan, sige, head ulit. Run ko yung head, control enter. Okay, I'm now getting 1, 1, 1, 1, apat na 1, and then 2. And I'm sure, 100% sure that you also got the same. You're getting the same sample. If you run it together with set.seed, could I have a confirmation that you got the same distribution? 1, 1, 1, and then 2, and then 1, 1, 1, 1, 1 again. Then yung 2 pang ano na, pang whatever. Yeah. Yes, thank you, Rap. How about the others? Okay, yeah, good. I was expecting that class. Kasi nag-set.seed tayo. So pareho yan. Okay. All right. So nag-create na tayo ng object, di ba, na PD. So ang nangyari dito, yung ano natin, yung data natin, which is cardio. So ang ginawa niya, ito 1, 1, 1, 1, 1. So the first 4 will go to the first group. And then the second one, the fourth one will go to the other group. Yung testing data natin. So we now split na natin yung data natin. No? We're going now to create Control Alt I. Let's now create an object. Let's call it train. So I'm now creating an object called train, Alt minus. And then it will be, okay, si cardio, di ba, from cardio, ang gagawin natin, okay, isa-subset natin where your PD, yung PD na create natin, itong vector na to, PD is equal to 1. And then, i-include natin lahat ng columns. No? So remember, anong ibig sabihin itong bracket na to? It's subsetting. So yung first dito will be your row, the second is your column. So yung column natin, lahat, isama natin. Pero yung row natin, for training data set, it should only be yung equal to 1. Alright? So if we view, natin view si train, no? Alright, so i-run natin to. Alright, take a look at this. Ilan na lang yung ano natin? Si train data. Wait, na-run ko ba siya? 2126 ba? 2126 pa rin. Dali Train is cardio. From that cardio, isa-subset lang natin yung PD is equal to 1. Yan, tama naman to. Ay, wait. Ito. Nga pala, no? So, yeah, Notice, plus, yung train, mali eh. Bakit 2,126 observations pa rin? Dapat 80% na lang yan, more or less, di ba? Kasi yung train, yung ano natin, yung in-split natin yung data, when we split our data, it was 80-20. Okay? Remember, di ba, we created this PD, partition data, PD ng tinawag ko, and then we're sampling it into two. One is 80%, the other is 20%. So dapat yung train natin, which includes all the number 1 dun sa PD natin, that should be more or less around 80% of 2126, so 116 plus. Why is it that the train data is still 2126? Okay, kasi mali yung function ko dito, mali yung code ko. No? Okay, so dapat PD, okay, that's why it's important not to use equal to, kaya nga hindi natin as much as possible ginagamit yung equal to. Kasi hindi equal to dapat yan, dapat double equal to. Okay, PD is equal to 1. Okay, so let's run this. Ito tama na to. Okay. Now, take a look at this. 1718 na lang siya. So 1,718 observations. Okay? All right. And also, ano natin, lagay natin dito, create our training data set natin. So our train data set. Yan. And then, of course, we can now create the other one. Create our test data set. Yan. Test data set natin. We can just copy this. Ito na lang. Sige, ito na. Palitan ko na lang. Control-C, Control-V. And then I'm going to replace this by test. And this one, so PD should be equal to 2. And our train here should be equal to testing. All right, so take a look at this. We're creating this object called test. And then we're using the cardio data set, which consists of 2,126 observations. Ang gagawin natin, from the PD object, iba si PD 1 or 2 yan eh. Diba? Gamitin niya yung is equal to 2. Is equal to 2. Okay, for the rows. And then, view natin, let's see. Okay, so you only have 408 observations here, which represents around 20% of your data set. Okay? So 408 lang tong ano natin, tong test data set. Okay, usually ganun yung yung ratio, no? So minsan I see 60%, minsan 65, depende din sa size ng data set natin. All right. So let me pause for a while. Okay, any questions? I mentioned a while ago that sometimes tatlong pag-split yan. So yung iba sometimes nag-i-include pa ng isang klaseng data set, yung validation data set. So merong training, and then my validation, and then my testing. Okay, good. Thank you. All right. So let's now, ganun na tayo. Imo-model na natin si training natin using decision tree. So, did you have an opportunity to do decision trees before in your other subject? Feedback, please. Kung nag-decision tree na kayo dun sa ibang subject nyo before?
No, sir.
Okay, good. Again, opportunity to learn class. This is now in the province of machine learning, no? Okay, so may bragging rights na kayo after this, after tonight, although hindi natin matatapos lahat to. But yung mga next sessions natin, aside from yung makeup class natin, i-allocate natin yan for our i-conclude natin yung efficient frontier at saka yung portfolio optimization using R. So, at least ito, kasi I was afraid na baka maubos yung time natin, hindi mo lang tayo nakapag-machine learning. At least ito, I'm happy that we're starting already with this one. All right, so let's now create, let's now use a decision tree. Decision tree model using, we're going to use the party package. There are several packages. Okay, so for a start, let's use the party package. So Control I. Okay. So how do we, i-ano muna natin, no? So, diba alam natin yung ano, yung i-library natin si Pacman, library Pacman. Okay, and then this is especially for you, plus kasi I'm sure hindi nyo pa na-load yung party. Right? Or you can do it, install that packages, and then a library party. Or you can do it this way. Para sabay-sabay na yung pag-load, pag-install at saka pag-load. Okay? So, okay na, no? And then if you check sa packages, paki-check, just making sure if you have the party package na dapat naka-check na yun, no? Kasi Pacman load na natin, ibig sabihin yan. So in my case, naka-check na. So kindly confirm, please. And then let's first take a look at the party package. You have the package already installed, class?
Yes, sir.
All right. So let's first take a look at the package itself. Sa description muna. It's a laboratory for recursive partitioning. Because ganun nangyayari class sa decision trees, no? Partition ng partition, split ng split siya ng split ng split until such time na na-classify na niya. No? In fact, itong decision trees, this forms part of a family of models in machine learning, yung sa supervised learning, which we call CART, C-A-R-T, okay? Which is your classification modeling using regression trees. All right, so let's take a look at yung description.
Sir?
Yes?
Sir, parang hindi po nag-load sa.
Hindi nag-load. Sige. If not, mag-install mo na lang. Install that packages. Okay? And then, i-library mo. Kung hindi siya, I don't know why it's not loading. How about the others? Nag-load ba using Pacman? Generally, pag ginamit natin si Pacman, tapos install and library yung ano, I like this kasi isang ano na lang to eh, isang function lang. Pload will install and load the package at the same time. So, paki-try please na mag-ano na lang, install that packages. Yan. Diba? Yung usual natin na partition. After running that, library. Okay. And paki-chat kung okay na. So, in the meantime, buksan natin tong description dito. Okay. Thank you, Rap. All right. So this is, I looked at sa packages, no? Pinype ko si party and then clinic ko tong party and then yung documentation. So lumabas to, no? Ito, description file. So it will bring us here. It's a computational toolbox for recursive partitioning. Okay. The core of the package is classification tree, C3. An implementation of conditional inference trees. So this is all about decision trees, which embed three structured regression models into a well-defined theory of conditional inference procedures. This non-parametric class of regression trees is applicable to all kinds of regression problems, including nominal, ordinal, numeric, censored, as well as multivariate response based on conditional, etc. No? All right, so meron ding C forest. Okay. All right, so these are the this is what this package is all about. So if I go back here, tapos party ulit, then we can take a look at the different functions, no? Ito yung mga functions niya. Okay? So I leave you guys to look at the documentation sa Quran. User guides, for example. Sige, click lang natin tong user guide. Okay, ito, for example, itong party, a laboratory for recursive. So my PDF, my source, kaya natin tong R code, for example. Alright, so yan, merong may sample, Okay, code chunk number 1, setup. Okay, so different examples here. So binibigyan niya yung code, no? Yun nga lang, hindi natin pwedeng ma-run dito. So if I go back here, if you want, you can go to the PDF itself. Okay, and okay, hindi ko lang ma-load ngayon, no? Access was denied. All right. Anyway, okay, you know what to do, class. So let me go back to our file. Okay, so let's start, class. Let's start making use of the party package. Okay, so gagamitin natin yung C3, no? As I mentioned a while ago, dito ulit. Oy, sorry, mali. C3, where is that? Here. Ito. No? We take a look at this. Conditional inference trees. Recursive partitioning for continuous, censored, ordered, nominal, multivariate response variables in a conditional inference framework. So this is the code. Okay, tapos may explanation siya dito. Tapos usually may mga examples siya. Okay? And then I leave you, class, to try to run this and study it on your own. Okay, so these are different examples. Notice may set.c dito, no? Para pareho din yung pag-partition. Okay, we can see asan na pinartition dito. Nag-partition ba siya? Okay. It looks like hindi siya nag-partition, ginamit na yung buong data. Okay, anyway. So let's create this model. So let's just call this first 3. Okay, so 3.1. Okay, lagyan na natin ng pangalan na 3.1. So this is our first model. And let's, for purposes of just reminding you kung saan galing yan. So I'm just putting there the namespace na party package. Okay, and then we're going to use the C3, this one. Yeah. C3. Okay. And then, ilalagay natin yung model natin. So we're going to use NSPF. Di ba si NSPF? I-regress natin. So shift. Ganito sa regression kay R, no? Ito yung dependent variable, and then what follows will be the dependent variables. So as a start, ang gagawin lang natin muna, okay, let's just use the 3 variables here. Okay, and then on your own, you can also use the other variables. Pero as a start, para lang makita natin yung how this works, let's use LB. AC, it has something to do with, apologies class, I forgot to get the, hindi ko makita yung metadata, which is, metadata is data about the data. What AC is all about, trying to recall kung ano yung AC. It has something to do with, basta about about body conditions, measures to ng hanapin ko nga yung metadata nito para clear sa atin. But what we're going to do is just use these 3 variables lang, LB, AC, and FM, in order to model or predict yung NSPF na categorical variable. All right, so how to do it in R is, okay, LB, okay, And R is very sensitive to spelling ng variable. You know that. So dapat, kasi yung variable natin dito, dali just to i-check ko lang, no? Names, para sure lang, names, cardio, okay, ito yung mga variables yan, no? Yan, LB capitalized, then, let me go back here, copy ko na lang to, Control C, then plus, Control V, and then plus, yung first three na lang, no? Plus FM. Okay, so we're regressing NSPF on, we're using the first three variables as our independent variable, okay, comma, and then we identify the data, our data is equal to, we're going to use the train data. So we're not going to use the cardio data. So ganito yung sa regression. However, sa regression, sa OLS, ang ginagamit na function is LM, no? Linear model. Okay, in case you haven't tried, if you have not tried doing regression in R, you use ang function ng LM, linear model, and then ganito din yung syntax. Pero ito, classification tree to, no? We're not going to use OLS here, ordinary least squares. All right. So that will be our model. So 3.1. So if you take a look at this, ano yung laman ng 3.1? It's a large binary tree. Okay, if we open this, okay. So marami siyang laman, data, responses, predicted responses, etc. Tingnan natin prediction dito. Alright, so it has it's actually a list, no? So marami siyang laman. So mahirap, it's quite difficult to understand it here. So good thing we can print. Okay, we can print our output. So let's print our output. So we can use either we type 3.1 or print 3.1. Okay, di ba pwede yung lang 3.1, ipiprint niya yung what's inside 3.1. All right? So if we print 3.1, what will we have? Okay, take a look at this. So it's hard to understand this, no? Parang may pattern siya na, okay, so this is like actually a tree, no? It's like a tree. Let's try to understand, kahit briefly lang kung ano yung laman nito. We're told here that there are conditional inference tree with 10 terminal nodes. Ibig sabihin yan, may 10 nodes na na-derive yung model natin. 10 daw. So you start first with this initial and then nagbabranch yan into different trees hanggang, ang sabi, 10 daw yung nodes na yung terminal. Alright? Ano yung mga 10 yon? Naka-identify dito yon sa model natin dito. It's identified here. Alright. So take a look at this. Number of observations, 1718. So medyo it's quite difficult to understand what's happening here. Okay? But in a nutshell, it tells us that magsimula sa AC. Okay? If it's less than 0.00834, okay, it will go to criterion 1. Ano yung criterion 1, class? Si normal to, di ba? So may decision kagad dito. Okay? If AC daw is less than 0.00834, then automatic. Yung ano niyan, may ano kagad, may output. 1 siya. Ano yung 1? Normal. Diba? Normal siya. Okay? Otherwise, if it's not less than 0.00834, tingnan natin yung LB. So, parang step by step siya, no? First, is AC, so let me go there. Ito yung testing natin, no? Is AC less than 0.00, natin. Let me copy this para Control C. Dito na pala. No? Sorry. It's here. Nasa ano pala natin? Nasa console. Ayan, ito. So, parang ganito yung naging ano niya. Well, hindi parang. Ito yung naging ano niya, model niya. Titingnan muna niya si AC. Is AC less than 0.008? Okay, yung first ano natin, yung first observation. Yes, it's less than 0.008. Therefore, ang prediction kagad niyan, normal to. Okay? N kagad yan. Now, let's see if tama siya sa prediction niya. Oh, mali, no? Sa first ano pa lang, sa first level natin, sabi niya na if AC is less than this one, then it will be criterion is equal to 1. So criterion is equal to 1. Dito sa unang ano, sa first observation, mali siya. Tingnan natin sa pangalawa. 0.006. Is 0.006 less than 0.008? Yes. So automatically, sabi niya, ang prediction niyan, 1 yan. Which is normal. Dito tama siya. No? So you get the idea, class? Paano nga please, pa-feedback kung naintindihan yung ano, yung concept na 'yon. Hello?
Hello, sir?
Yes.
Yung second observation, 0.006 yung AC.
Yeah.
Greater than.
So, greater than siya sa 0.0008. So,
0. Ay, wait. 0.0. Ay, oo nga pala. No, sorry, na-misread ko. Okay. So, yung first na ano, di ba? Is AC less than 0.008? Is AC less than this one? So, tingnan natin dito. Hindi, di ba? So, ang susunod na gagawin niya, pupunta siya dito sa LB. Is LB less than, kasi parang step yan eh. Okay, if it's less than 0.008, then conclusion kagad, normal. Pag hindi, punta tayo dito sa second step. Tingnan naman si LB. Is LB less than 136? So yes, LB is less than 136. Then ano yung conclusion? 1 pa rin. You get the idea?
Yes, sir.
So tama siya dito, no? Tapos if not, pupunta naman siya sa FM. Alright? So, yun yung pattern niya, no? So that's what it does. Alright? So let's take a look at okay. So ang gawin natin, mas makikita natin yan kung i-plot natin, no? Kasi ito yung parang textual diagram eh. Mahirap siya maintindihan. But if we plot this, lagay ko na lang sa panibagong code siya, Control Alt I, and then let's plot. Let's plot the 3.1. Okay. Run. Alright, let's see what happens. Tingnan niyo yung plot na to. Yan. So ito yung model, no? This is the model. Yan. So ito, naka-round off lang siya, no? Ito magsisimula if is AC less than 0.001? Okay. If AC is less than 0.001, then titingnan si LB, no? Titingnan si LB. Naka-round off to, di ba? It's 0.008, di ba? So hindi naman niya ma-capture dito sa diagram yung actual na 4 decimal places. So naka-round off lang to dito. If it's less than 0.001 rounded off, it will go to LB. Is LB, this one is less than yata to, no? Less than 136 kasi ito greater than 136. If it's greater than 136, then dito siya. No? Pupunta siya dito sa node na to. So ano yung node na to? Yung node na to, this one, node 6, okay, it's a probability distribution where distribution ni 1, okay? Take a look at this. So merong merong probability siya. The probability that it will be 1 is this amount, around 0.4. The probability that it will be 2 is around 0.5 or 0.6. So malamang 2 siya, no? Suspect. Okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 terminal nodes. Ito yung sinasabi niya na 10 terminal nodes. Okay? So yung decision tree na yan, okay, it takes a look at the details of the observations, and then it will ultimately classify it as belonging to node 1, node 2, node 3, hanggang dito kasi node 1, 2, 3, 4, 5, 6, and this is 10. Okay, so we have 10 terminal nodes. Okay, all in all, there are 19 nodes, 10 of which are terminal, the others are not terminal nodes. Yung terminal nodes, dun yung decision. Okay, dun yung decision. So the decision is given is a probability distribution. So dito, ang laki ng probability, oh. So ito, 100% nga eh. Diba? Tingnan nyo, 1, no? So what's this? If AC is less than 0.008, and then we go to LB, if LB is less than 136, and then if FM is greater than 0.112, 100% sure tayo na pathologic yan. That's the meaning of this diagram. Okay? And it's different from an OLS, no? Okay? So ito na yung ito na sinasabi natin na supervised learning using machine learning, itong decision tree. So so lahat ng respondents natin, lahat ng observations natin, yung 1,000 plus, it's classified here, no? Either dito siya sa node 4. Kung node 4 siya, it will be classified as 1, normal. Kung node 5 siya papasok, it will be classified as 3, pathologic. Kung node 6 siya papasok, it will be classified as around 50%. And then etc., etc., etc. So we can see here that marami dito, classified siya as node 1. Okay? All right. Any questions about this? Clear ba so far itong itong regression tree natin?
Ba naman?
Clear ba? Okay. Actually, madali lang siya interpret, no? The good thing here is that ang bilis ang generate, di ba? Ang bilis ng machine learning. And you can try that with kaya nga it will not be lang kasi that's why we use only 3 variables para mas kitang-kita kagad natin. But you can of course use all the variables. By the way, hindi pa natin tinignan yung no? Okay. Tingnan nga natin yung let me see. So, ilan ba yung anong function yun? Is it x tabs ba? Okay, x tabs. Okay, cross tab ni cardio, and then NSP F. Okay, error. Mali, no? Ano yung function ng x tabs? Sandali. X tabs. Okay, tinan ko lang yung syntax. Uses a contingency table. And wag na lang x tab, table na lang. Gusto ko lang makita yung distribution. Table, then cardio, and SPF. Tama ba yung syntax ko? Ayan, okay. That's it. This is what I want. So, ang sinasabi natin dito, ilan ba yung normal dun sa ano natin, sa data natin? Ang normal, 1,655, dalawa yung 295 dun sa ano sa ah, P, and then yung pathologic 176. Okay? We can actually get the cross tabs of this. Hindi ko lang maano yung function. Pero yung table na lang. But if we, okay, let's just take the proportion 1,655 divided by the sum. Hindi, ano pala? N row ng ano? N row ng cardio. Okay. So ilang percent yung ano? 77% yung 1. No? Tapos yung C2, that will be 295 divided by N row cardio. 13% yung 2, no? Tapos yung pathologic 176 divided by N row ng cardio. Okay? Of course, yung difference lang 8%. Now let's try to see kung na-maintain ba yung ano, na-maintain ba yung proportion ng ano ng table, and then tingnan natin yung train data natin, no? Train NSPF. See, 1348, and then let's see 1348. Tingnan lang natin kung medyo kahit pa paano na-maintain yung ano, yung proportion ng train. Okay, 138 divided by number of rows ng train data set natin. So more or less, no, 77, 78, okay naman, no? Kasi ang danger lang nito, baka pag hindi na randomly generated, baka magkaroon ng ano ng bias. Kasi kunyari, naging 92% yung sa ano, yung 1. Tapos konti na lang yung napunta dun sa 2 at saka yung 3. Okay, I hope you got it, no? I hope you understood what I was saying. What I'm saying is that I hope na maintain yung ano yung proportion. Kasi dito 78% yung nasa normal eh. So dito 78%, okay? If we check yung 226 divided by 226 divided by N row ni train. Okay, 13% and practically the same. So maganda yung pagka-split niya. So na-maintain pa rin yung ano, more or less yung proportion ng yung normal, okay, ng suspect at saka ng pathologic. All right, then may mga iba pang functions ng ano ng pag-plot, no? Okay, we can use the plot. Okay, plot train that one. Okay, and then pwede nating kasi may types to, no? Okay, we can use a type is equal to simple. Okay, let's see this. Plot ng train that one, and then simple lang. Okay, may error ako. Tama ba? Ay, hindi train that one. Sorry, 3.1. So 3.1, control enter there. Okay. All right. What you can see here is that instead of the bar chart, ang binigay sa atin yung mga probabilities niya. So you have here that the 10 nodes ng ano ng terminal nodes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I believe there's a way to adjust the size, okay, but I haven't tried it. I haven't explored how to adjust this size. But what you can find here is it's actually it's more informative kasi binibigay sa atin yung ano yung figures mismo, no? Hindi yung not the not the just the graphic ng ano ng bar chart. ito binibigay talaga yung probability, no? 0.722 at saka 0.278. Okay, 0.722, 0, and then yung 27.8. So this is for normal, suspect, and pathologic. Alright, dito 100% as we saw a while ago. 100% yung pathologic. So it follows this path, no? Itong path na to, 1, 2, 3, 5. So yung path na yan, 1, 2, 3, 5. It brings us to node 5 and then N11. Ano ibig sabihin ng N11? 11 dito ng respondents na punta, 11 ng mga respondents na punta dito sa node na to. Dito, 314 lahat. Okay, dito, 18. Okay, dito, 28. Nakikita nyo yung N na yan. It gives us how many of the respondents went to this specific node, terminal node. Okay, any questions so far, class? Okay, no questions. All right. Then what's good about yes?
Pwede ko na-generate yung pangalawang plot.
Okay, this
on my
one.
end.
Ito.
Yeah, I typed
Sige.
that. Pero
Sige.
hindi ko, nag-capital S yung sa akin, sir. Let me try. Kung gawin kong small S yung sa simple. Baka yun.
Yun.
Ayun, sir. Okay na pala.
Oo.
Yun pa rin.
Yan. So very sensitive si R sa sa mass spelling. Okay. Naging capital S. Okay. All right. Then we can modify the model a bit, no? Dito sa C3, no? Tinala natin sandali yung C3, ah. Ano pa yung mga functionalities niya? Question mark C 3. Ito, no? Ito yung functionalities niya. May controls na pwedeng ilagay. So ano yung C control na to? Tingnan natin. An object of class 3 control from the C3 control argument. So pwede natin tingnan yun. Asa yung C3 dito? C3 control. So, criterion exceeds the value given by the minimum criterion specified in the C3 control. For example, when minimum criterion is equal to 0.95, the p-value must be smaller than 0.005 in order to split this node. So, which means that you can control the splitting of the node. Okay, pwede nating makontrol yung pag-split niya. So, for example, ang default yata is 0.95. No? Okay, ito yung sa p-value to. No? Sa p-value siya. So, let's try to experiment. Baguhin nga natin yung ibig sabihin, kunyari, kailan magi-split yung yung 3? Doon ang nakalagay ang default 0.95%, para may 0.95 confidence level tayo. Okay, bago mag-split. So what will happen if we relax that a bit? No? So gawin natin kunyari ang minimum criteria natin, let's say 0.9. Tapos meron pang mean, pwede natin yung mean split. Ibig sabihin, hindi basta-basta mag-split. Ang minimum na pag-split niya, tingnan ulit natin to, ha? Kasi dito may 18, no? May 7, may 28, may 12. We can also control, no? Mag-split lang, may minimum level. So hindi pwedeng 1 lang or 2 lang or ito 7 lang, ano? Okay, so ibig sabihin, we can control yung kung ano yung minimum dapat na number of observations bago pwedeng i-split. So hindi pwedeng mapunta sa isang terminal node yung let's say isang observation lang. Okay, so let's do that. Let's copy our model first. Ito. Let's copy this. Okay, so let's call this, tawagin na lang natin 3.1a. Okay, and then, ilagay natin dito yung, yung controls, no? Ano yung function niya? Controls, no? CT control. Controls is equal to ito, CT control, C3, yan, C3 control. Then i-identify natin. Mag-try lang tayo. Kunyari, kasi ang default niya 95% eh. Yung minimum criterion. Here, sabi niya dito, minimum criterion is 0.95. Let's try, copy ko lang to. Control C, Control V. Okay, ano ko nga to para medyo. Okay, minimum control is babaan natin ng konti, 0.9. Alright? Then we can also, pwede natin magamit yung minimum split. We can split, yan, no? So if you check yung C control plus, makikita niyo yung mga different parameters na pwede pang gamitin. So I've tried using this, yung mean split. Okay, let's make it mean split is equal to 50. Okay. So na-close na natin si C control, close. Okay, and then comma. Tama ba? Okay. Dito ko nalagay yung Control X para hindi nakakalito. I'll put the data here in front. Comma. Yan. Okay. All right. So kindly check, class. Ito yung model natin. Same model that we used a while ago. And then yung data natin is train. And then yung controls natin, controls is equal to C3 underscore control. Minimum criterion. So may mga iba pang class yung C control, no? There are others. Yan. May test type pa nga, no? Yan, ginawa natin minimum criterion, minimum split. Okay. May buckets pa nga, minimum bucket. Okay, ibig sabihin, hindi pa pwede magkaroon ng model na less than 7 yung buckets, yung terminal nodes. Alright? So there are several splits there. There are several functionalities there. Let's just focus on this simple one. So run natin si 3.1, 1.a, and then i-plot natin. So, Control Alt 1, okay, plot 3.1a. Okay? Okay, and as usual, ito na naman, no? Ayan. Pero gawin natin yung mas, okay, check na. Sige, dito natin. Plot 3.1a type is equal to simple. All right. So we have this. Nabago yung model, ano? Ilan yung naging ano? Ilan na naging... How many terminal nodes do we have now? 1, 2, ilan na? Dumami na, no? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, naging 12 na. Ha? 12 na yata.
Sure, tama. Mhm.
12, no? 12. And why did that happen? Kasi rinelax natin yung ano no? Rinelax natin yung criterion. Kaya ginawa nating lower, 90%, pwede na siyang mag-split. Dito kasi sa default, 95%, pwede siyang mag-split eh. Yung mean split na 50, okay, so it means, so kapag, parang mali understanding ko na na dapat ang minimum na number of observations sa isang terminal node is equal to 50. I don't think that, hindi pala ganun, no? I think, magi-split lang siya, dapat at least 50 siya, no? Minimum of 50 bago siya mag-split. Ibig sabihin, if it's already less than 50, hindi na siya pwede mag-split. No wonder, mas dumami yung nodes natin. Okay? So that's the meaning of, I believe that's the meaning of mean split. No? It can only split if the number of respondents, kunyari dito sa portion na to, okay, hindi lang masyado makita, no? A particular node can only split if it has at least 50 observations in it. Kasi yung mga observations class, nasa split yan, di ba? It gets split. So from 1716, if it's less than 0.001 yung AC, may mga papasok dito na observations, di ba? From the 1,700. The rest will go here. Di ba? Okay, so every node here has a number of observations. So yung mean split, kapag if it goes to a particular node, tapos kung more than 50 siya, pwede pa yung mag-split. Pero kung yung particular node na yon, if it's already less than 50, hindi na siya pwedeng split. No? It cannot be split anymore. Okay, kaya tinan itong mga to, no? Ito in this case, 28 yung node na to, itong terminal node 23 na to. Since it's less than 50, hindi na siya pwedeng split. Kaya ito naman, kahit 144 siya, pero wala na-consider na lahat ng in other words, hindi na pwede siyang wala nang pwede siyang sumunod na na 3. Kasi from AC, and then LB, then another LB, and then here. Kumbaga terminal node na siya. Hindi na siya pwedeng mapunta sa FM. No? Hindi na siya pwedeng matest as regards FM. All right. So these are modifications. Okay. Kung rinelax natin yung minimum split, mas dadami pa yon, di ba? Mas dadami pa yung yung model natin. All right. So, any questions so far, class? So for example, sige mag-experiment lang tayo. Just to clarify that point. Okay, let me copy this. And then let's be more strict with the split. So dito ang gawin natin, yung minimum criteria natin, gawin natin 0.9 0.99. Yan, 0.99. Tapos yung minimum split natin, if we make this higher, edi hindi na siya basta-basta pwede mag-split kung kunyari 100. Kung 100 na lang yung natitira sa kanya, then hindi na siya pwede mag-split. Okay, let's call this 1B. 1B, and then ipa-plot na natin si 1B din. Control C, Control V, put 1B here. All right, so let's run this. We're creating this tree, that 1B. Okay, anong ginawa natin? Yung minimum criterion, 0.99. Okay, and then min split 100, minimum split. Meron nga minimum bucket, no? Ito, minimum buckets, kung ano yung minimum number of buckets na pwede. All right, so let's run this. Let's see what happens. Mas konti na lang, no? 1, 2, 3, 4, 5, 6, 7, 8 na lang yung natin. 8 na lang yung terminal nodes natin. Okay? Alright, ang ano lang yan, class, ang danger din, pag masyado namang masyadong konti na lang yung natin, yung terminal nodes, then it might not be accurate, no? Kasi parang yung pag split ng data, yung pag-classify whether NSP, it becomes broader, no? Pag broader kasi, mas nagiging prone to to generalizations na it could lead to errors or misclassifications. All right. So clear so far, class, yung pag-control natin ng tree natin. Class. Hello.
Here, sir.
Okay, are you still
Yes, sir.
with me?
Clear pa.
Okay.
Yes,
Akala ko, iniiwanan nyo na ako eh. Natatampo na ako sa inyo. Okay, sige. Alright. So may model na tayo, di ba? So we can either use yung 3.1, 3.18, 3.1b, no? Okay, so gamitin natin si 3.1, yung 10 na terminal, yung default na, yung hindi na natin inano yung minimum criterion. So minimum criterion nun, 0.95. And then, ang minimum split niya, ang default ba, ano yung minimum split? Okay. Hindi nakalagay dito. The minimum in a node in order to be considered for splitting. Okay, naka-define ba kung ano yung minimum split niya? Yung default? Okay, we'll have to look for it, no? I don't find it here. But sa documentation niya, makikita natin yun. Kung ano yung default na minimum split. Ito 20. Baka ito, no? As usually, pag ang dinalagay sa syntax ng yung minimum criteria niya 0.95. So the default is 20, no? Ibig sabihin, kung less than 20 na lang yung natitira sa node, hindi mo na pwedeng i-split 'yon. All right. So let's now, ito na interesting. Tingnan natin kung yung prediction ba natin kamusta, no? All right? So what do we choose sa pag-predict natin? Ano gagamitin natin? Si .1 na lang, no? Si .1b kasi mas konti na lang, di ba? Kasi siguro, sige, let's do 3.1 and then I will leave you, class, to compare, no? Kung sino mas maganda, si 3.1a, 3.1b, as compared to 3.1. So let's first predict, no? I-predict natin yung i-predict natin using our model yung dependent variable natin. I-test natin siya, no? So let's call this predict the outcome variable NSPF using our tree model. Okay. So let's create this object, tawag natin. Predict P.1, no? Para partner ni 3.1. Okay. So ang function natin, we're going to make use of the predict function. Predict, tapos ang model natin yung 3.1, right? And then using the train method. The train method. All right. P.1, okay? We use the predict function. All right? Enter. So meron na tayo ditong ano, no? Ito. So P.1 natin class, ito na yung ano natin, ito yung mga predictions. So vector ba siya? Okay, values. So tingnan natin view P.1. Okay. Ano siya, no? So ito na yung mga ano, yung mga predictions. All right. Sige, i-print na lang natin. Let's use the head P.1. Puro first 20. Okay. So ito yung mga predictions niya, no? And then let's compare it with head ng train NSPF. Okay? And then 20. Okay, pinapaprint ko dito yung what's inside the elements of train sa train data set, yung NSPF, and then first 20 para may comparison tayo. Ayan. Okay, tingnan natin, ha? All right. So, ito yung prediction, di ba? Yung P.1. Ito yung actual. So, yung una, the first one is wrong, di ba? Wrong prediction. The second one is correct. So, lahat ng mga nagmamatch dyan, tama yung prediction. Pero dito, marami ding mali, di ba? Ito yung actual 333, tapos ito 1111, di ba? Tapos 2, okay? Okay, so we can see here, at the onset, makikita natin yung mga errors ng model, no? Yung errors ng pag-predict natin. Okay, you follow so far, class?
Yes, sir.
Okay, now let's create a table. I-create natin yung table natin, comparing your actual values with your, okay. So ilagay ko lang dito para ano, head ng P.1 and then 20 for comparison ng head ng train $NSPF and then 20 din. So 20 observations side by side na comparison kung sino yung tama at saka ano mali, no? But of course, since 1,700 plus yan, so and dapat mas maganda natin makita yung buo. Let's now create a table, no? Let's call it tab.1. Okay, let's create this table. Yung table natin, okay. Okay. Let's use a table function, yung katulad ng kanina, no? So anong ilalagay natin sa table natin? Ipalagay natin to, yung predict natin, no? Okay. So let's give a name to the predicted. We call it predicted. And it's equal to the values of your sa predict ng 3.1. Okay? So gagamitin natin yung predicted values ng 3.1 versus, okay, side by side siya or versus, this natin lagay. Let's call it actual. Diba? Ano yung actual values natin? Yung actual ni training dataset, parang yung kanina, train $NSPF. Yan. Okay. So what are we doing? We're using the table function. Sa x-axis will be your predicted value, and then sa y are the actual values. Parang yung ginawa natin kanina, pero ito, yung count to, no? This will be the count. Okay, so let's run this. Okay, you now have this. It's a table, no? It's a table, and then, so i-print natin. Let's print now our table. Print, or just type print, or just type tab 1. Ay, asan na yan? Na-delete ko ba? Okay, Control Z. Na-delete ko, sorry. And then print tab that one, table that one. Print natin. There. Okay. So this is a print out of, diba yung predicted natin? Okay. So sorry, predicted yung nasa y-axis ito. Actual yung nasa x-axis. So let's see. Okay. Predict natin na 1, actually 1 siya. So ito tama. Yung diagonals natin, these are the correct predictions, no? The ones that are off diagonals are the wrong ones. We predicted it to be 1, actually 2 siya. No? We predicted it to be 1, actually 3 siya. So we predicted it to be 2, pero ang actual niya 126 yun. Pero yung 2 na predict natin, pero 2 din siya, 156 tama, no? So predict natin na 2, pero it turns out it was 332. Alright, so yung diagonals natin dito are the ones that are correct, okay? And the ones that are off diagonals are wrong. Alright, so i-compute natin, class, kung ano yung tama natin, ilang percent yung batting average natin. Okay, how many percent are correct and how many percent are wrong? Okay, so we'll just sum up here. Isum natin. Sum natin ng diagonals, no? Ng tab.1 natin, table 1 natin. Okay, so that will give us, okay, kung kunin natin to, no? That will give us 1389. 1389, yung 122, check nyo lang ha. 1222 plus 156 plus 11. So yung tamang predictions natin, yung nasa diagonal, and that is 1389, which is correct. No? So tama yung function natin dito, 1389. Alright, then, okay, kunin natin yung ano, the diagonals, Control C, Control D, then we divide it by the sum of your tab 1, tab.1. Sum natin siya, yung buo. O kaya yung n row ng ano natin, ng string. Kasi yun ang buong ano natin, di ba? Yun ang buong data natin. Alright, clear ba tayo, class? Clear? Enter. So we're 80%. Okay? We are 80%. We can tawagin natin tong ano ba? Correct, no? Anyway, see that one na lang. See that one, yung correct natin na proportion. Okay, so see that one is 80%. Therefore, ang ano natin, ang wrong proportion natin, wrong, that one will be, sorry for the name, hindi na ako makapag-isip. 1 minus C that one lang, di ba? Right? So that's, ay mali. Saan ako? Ayan, 19%. Okay? So we can just put here a parenthesis. Okay. And then I'll run both. Okay, I'll run lahat para, yan. So yung tamang predictions natin, 1389, which accounts for 80% of the whole sample. Okay, clear, class? All right. So I'll leave you to look at sige, gawin na natin dito, no? I-compare nga natin to dun kung 1B ang ginamit natin. kung ang ginamit natin ng model 1A, what will happen? Oh, close ko lang to. So let me copy this, Control C. So what if we chose, if you're using 3.1A model. So this will become, gawin natin 1tab.1A to. And this one becomes 1A, di ba? Alright, yung actual natin pareho pa rin. So what happens if we use yung 1A? Si 1A, di ba, mas marami siyang mas maraming, naging 12 yung terminal nodes yan, di ba? Okay, so let's see. Okay. All right. 1304.95.11. So let's just compute for kung ilang percentage yung niya, yung tama niya na prediction. So this should be 1A. And then gawin ko na lang tong C.1A. Oops. Tab 1A. Para madali nating A. Alright, so if we run this, okay, 1,410 yung tamang observations niya, no? 82% yung yung correct, okay? Which was expected kasi we have more terminal nodes, no? And you'll be able to guess, right, that if we use on the other hand that 3.1b, this will be the worst of all, no? Copy natin to, Control C. Kung 1.b yung ginamit natin, which became really quite broad, no? Okay, so let me call this one .b, .1b, .1b, B, 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 B. Okay. I expect this to have more. Okay. There. Okay. There. All right. 1389, no? Si 1B. Ano si 1A? Ano si 1? Ano na si 1? 1389, pareho lang.
Yes, sir. Parang pareho nga lang.
Pareho lang, ano? Si 1B, tama ba yung ko? 122, ito. Si 1 is, wait baka, tama ba yung pag-code natin dito ng 1B? Kasi parang parang, baka nagkamali ako dito. 1B, tama, 31B, di ba? Right? 31B. And then, okay, tab 1.1b. Tab 1b, tama. Yeah, it's correct. So, turns out na pareho lang si si 3.1 at saka si 3.1b. But, si 3.1a was more, let's say, had a higher success rate in predicting as compared to the two other ones. All right. So, right. Okay. So let's end na lang with just looking at our what if we run this dun sa natin? What if we run this dun sa test data natin? Kasi ito training data yan, di ba? So we're going to run this with the model that we haven't with the data which haven't been seen by the model. Okay, do you get me, class? Gagamitin natin to sa data ngayon na hindi pa nakita ng model natin. Right? So let's use, punta muna tayo kay ano. Sige, so use the model to predict our test data. Okay? Sorry class ha, I know it's already time. Pero tapusin na lang natin tong ano, kasi mabibitin pa tayo eh, no? Ito na lang naman yung test data natin. So what do we do with this one? What do we do with this one? So i-predict natin, predict P dot, ano ba ginamit natin? Sige, P dot 1, anong tawag natin dito? Test, no? Kanina P dot 1, yun yung training natin, no? Ito naman, just to distinguish, P dot 1 underscore test o P dot 1 dot test, pwede rin. And let's predict, anong model ang gagamitin natin? Model 3.1, no? Okay. 3.1 or yung pinaka-ano sa atin, pinaka-accurate si 3.1a, di ba? Pero let's use first yung 3.1. So P.1 underscore test is we predict. Okay, so i-predict natin yung object natin using 3.1. Okay, yung model muna natin at 3.1. Pero ang data na gagamitin will be yung test data na, yung test na. Hindi na train. Alright? So we're going to use the same model. Kasi yung model, di ba, pag ganito yung LB, ganitong gagawin. Pag ganito yung FM, pag ganito yung AC, ganitong gagawin. So you are using the same model, but this time, we're going to use it on the test data and see how our model will fare if we're going to use it on the test data. Okay? Clear yung class? Alright? So this one, okay, tingnan natin itong ano? Okay, P.1 test. Alright? By the way, I forgot, no? Pwede rin nating i-generate na Control C, Control V. Ano kaya? Pwede nating ang i-generate. Ito kasi ang gine-generate nito yung values, no? Kung 1 ba, 1, 1. Pwede nating na ang i-generate are, instead of the values, pwede nating i-generate probabilities. Okay? So we can write here type is equal to yung probabilities. So what will be generated are not the final values yung 1, 1, 2, 2, 2, but rather the probabilities. Control Enter. If you take a look at this, all right, list of 408. So what you can find here are probabilities. No? So for example, ito yung observation number 1. Ang probability niya na 1 siya is 0.98. Ang probability niya na na 2 is 0.004. And then the probability of it being number 3 or and di ba NSP yon, di ba, is 6%. Right? So instead of ito, ang equivalent ito 1 to, di ba? Ang prediction na dito 1 kasi 98% na normal eh. Di ba? Ito ang equivalent na dito 3. Kasi 100% na na pathologic, no? So ito we're just looking at it from the probability perspective. Okay, clear to class? Clear? Clear ba? Hello? You still there? Tatapos na tayo. Ito na, yung misclassification na natin. Okay, tingnan natin kung based on this, no? So let's now, i-ano natin, mag-create na tayo ng yung table natin. No? So we use tab.1 underscore test for our test. No? Okay, and then it's also the same. Copy na lang natin, no? Para mabilis tayo ito. Table, Control C, Control V. So that's table. Okay. Ang predicted natin is so ito, no? Ay, wait, hindi. Ang predicted natin is table natin predicted is sorry, this is 3.1. Okay? And then ang actual natin is yung test. Yan. Yun ang difference, no? Yung test data. Okay? And ang ginamit natin yung 3.1 ng method, di ba? Here, yung 3.1. Of course, we can use the 3.1a or the 3.1b. So sabi ko nga, i-compare na lang, no? Print natin si 3.1 .1 underscore test. Alright? Let's run this. Okay, ano yung error ko? Error. Arguments must have the same length. Okay, so may mali ako dito, no? P.1b. Ang predicted natin is ito, sorry. Hindi dapat to. Dapat 3.1 so dapat, sorry dapat ito. Yung test, no? So, alright, kasi yung P.1 underscore test, ang laman niya ito. Alright, so we're just saying that the predicted value should be equal to this one, which is equal to this one. Yan. Alright, so run. Okay, so ito na, no? Note, mas konti siya, di ba? So ito yung mga tama, 274, 48, 1. And then let's see, i-run ulit natin to, yung proportion niya, this one. Okay, and we end in event end here, control V. So ano yung ano natin dito? Yung tab natin ito, yung table natin, control C. Okay, control V, right? And then C.1, okay, let's call it test. W, wrong, test. So this should be, ito yung table natin. Control C. We're replacing the table. Okay. 1 minus C.1, mali ito, underscore test. All right. So ito na yung sa test natin, no? Run. All right. 79%, no? So our model was able to predict correctly 79%. Yung ano, yung kung N or S or P ang wrong natin. Pretty good, no? Kasi halos pareho lang siya dun sa ano. And it's and it's 3.1, no? Yung 3.1a na mas accurate, okay, I leave you guys to check kung how our model performed with the test data if we use the 3.1a. Kasi di ba dun sa training data natin si 3.1a performed better, no? All right. Okay, so all right, so that ends our discussion tonight. That's the first part of our discussion on decision trees. We'll have more So from now up to the end of the term, panay machine learning na tayo, no? We'll just have, as I said, a special session to finish yung ano natin, yung portfolio. All right? Did you learn something tonight, class?
Yes, sir.
Yes, sir.
Okay. Interesting ba? Interesting si decision trees?
Yes, sir.
Hindi, boring. Parang
Yeah.
parang masama yung loob nyo.
Dito lang yung command, sir.
Okay. Sige. Right? Thank you so much, class, and have a blessed evening ahead.
Thank you, sir. Good
Okay.
night
Thank you,
po.
sir. Good
Bye-bye.
night.
Thank you. Good night.